something good to keep with you as you go back and look over to really see what they're. And you see the paragraph on the back where they really explain everything in detail. Part B, work it or no? Yeah. Part B threw me a bit. I told you because of that R. So they tell you that 2 pi 0 to 4 R f of R dr, and then they tell you to use a right Riemann sum. So I always go back in my little chart and I draw out I do this 2, 3 to make sure I got the right number of intervals and I don't get lost or confused. And I always do that. And then since it said right, I even went in the top and I said, okay, I know I'm using right Riemann sum, so I'm gonna. I try to make it because I'll get myself confused if I don't. So just if that helps you, it helps you. If it doesn't, don't do it. Okay. So I got 2 pi outside, right? 2 pi, and then I'm going to multiply that by, so each time what I'm doing the area of the rectangle, but I'm also multiplying by the actual R value for that one. So in other words, this one goes 0 to 1, 1 and 2, right? So the R value, this is R, this is f of R. The R value is 1, and then I'm going to multiply that by, again, it's right Riemann sum, so I'm going to do 2. And now I do the distance from 0 to 1, which is 1. Okay, so this is my rectangle. This is my R value there. That's why I said that R way threw me on this problem. So if you got thrown on that one. And so now again, the next one was the next point, 2, 6. So then for the next one, I do, the R value is 2 times, I'm using the 6 for the width and then the height, or for the height, and then the width from 1 to 2 is 1. So again, here's my rectangle and this is my R. Again, I think it's just, just funsies. So if you go through and do all this, and of course you had a calculator on this one for whatever good it did you. 2 pi times 134.5. Still a rate, because remember this was centimeters squared. This was milligrams per centimeter squared. So back off one of that, it would just be milligrams per centimeter. So it's still a rate, but it's still. They didn't ask for. I don't think they had anything in here with the units, which was odd. I left it at 269 pi. I did not put 845.088, but whatever floats your boat. How about C? I hope everybody got C. Yeah, no. Because it's always increasing on this interval, then a right Riemann sum would be an underestimate. Yes. Is it? Oh, yes. So let's see. Why would I write that? If I just drew it out. I didn't do that. I guess I would have lost a point. Why did they do that? The derivative of because here's why. Because B is not just, it's not just the table, it's R times the table. So you have to take that into account. So you have to do product rules there. So I would have lost a point on that. Gross. This one was nasty too, I think. How about part D? Okay, have a good day. So part D, I had very little work for part D. It was strictly calculator, but my calculator really had to think. It got bogged down on this one. All right, so you got average value, right? 1 over b minus a from the integral from a to b of g of r dr, and I just put g in my y1 and went from there. 9.875, yeah. Yeah, so the average value here, are you talking about how you put it in your calculator, or are you talking about? So for y1, I input this 2 minus 16. And listen, the first time I worked through this one, I was like, something doesn't seem right. My calculator was in friggin' degrees. So make sure you check those calculators and they're in radians because you'll get the wrong answer. So I put that in y1. And then my average value is, of course, 1 over, so it's b minus a, which is 4 minus 1, the integral from 1 to 4 of g of r dr. So what I did in my calculator was I said that int, and I called up y1, x, and then I went from 1 to 4, and all I did was divided that by 3 when I was done, because I've got to multiply by 1/3. So you should get approximately 9.876, but then the question says, when is g of k equal to that value? Well, since I already had this in y1, I just went into y2 and I entered this. And I tried to put it in like this initially, but my calculator just bogged down on me. So I just ended up stopping it and putting 9.876 here, and then found the intersection of the two. Yeah. That's smart too. Find the zero of it. So either way is fine. But definitely use your calculator to find those hard points. Yeah. So I plugged it in Y2, like Jalen said, and I found the intersection, second calculate intersect. Jalen said he kept his in Y1, he just added a minus 9.876 and found the zero, and that works also. Either one of those two ways will work. You looking at two? The K part. Of D. So once you found this value, you got that. So I need to know where this equals 9.876, right? Or actually not this, I need to know where G of R equals 9.876. So I can use my calculator to do that. Since you've already got G of R plugged in Y1, you can do it one of two ways. You can say your Y1 is, of course, G of R. You can say minus 9.876, and you can find where it crosses the x-axis. Or you can leave your Y1 as G of R, and then Y2, you can put 9.876 and find where they cross. And that'll give you your solution. How about number 2? Did good on this one? Look at you go. That is awesome. I hate when they throw second particles in here and stuff. Like, throw that in for a part D, but don't throw it in the stinking beginning. Great day. So lots going on here, two different, but pretty straightforward as to what they're asking. Positions, you had to remember to add in that initial position if you didn't. And again, it was calculator, so let the calculator work for you. Yeah. Yes, because you're going at time 1. I think part D took it to pi, but part A took it to 1 second. The definite integral, yeah. Yeah. What about number two? Any of them that I need to work? Are you still looking at it? Yeah, go ahead, go ahead. It's a lot. I know it's a lot. My calculator bogged down on part D trying to do that absolute value of that velocity equation, but I always get nervous when my calculator starts thinking that long, like I've done something wrong, and I'm going, ah. hmm I think that's fine. I think that's fine. I had to draw a little picture of them going along because I couldn't figure out. I knew they were moving in opposite directions, but I couldn't tell if they were moving in opposite directions towards each other or. So I just did a little. I said if this is 5, this is where P starts. This is 10. This is where Q starts. At time 1 second, I know that Q is at about 8. I know that P, and I don't even know that this would give me enough justification, but it was enough for me to see what they were doing. Then I could kind of justify what. Yeah. Yes, because that would be the sign of, yeah. Yes. 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 Y'all are one of my best classes with particle motion, I feel like. I don't know if it's because we drilled it so hard when we did it, but y'all do really well with particle motion for the most part. Don't understand particle. I know that's what I hate about spring break being where it is because you just we're on such a drive and then boom, yeah. Or take the exam a month earlier, yeah. Okay, but speed is different than is it speeding up or slowing down? That's two different things. So yes, but anything else while we're there before we move on to three? Three was the doozy. Yeah, on two. So I let my calculator do everything on D. I have very little work. I didn't look at the scoring to see if I got all the points scored. I did total distance traveled of P. I should probably look before I say I'm showing you how to do it. Make sure I got needed the. Oh, look, I did exactly what. I didn't interpret my answer. But okay, so I said total distance of P is the integral from 0 to pi, and then I did this. And I've had to learn because time restraints will really get you. If there's anything that you can do to kind of save time, it's hard for me not to write that whole function in there, but it's already been defined in the beginning, so there's no sense in rewriting it. Just write V sub P of T, absolute value. So I already had that in Y1, right? I think it was in Y1, yeah. I already had it in Y1, so all I did was I wrote this, and then I took out my calculator and I said function, integral, and then I did absolute value on my calculator of Y1 with respect to X from 0 to pi. That was all I did. And I just put equals approximately 1.931. And this one took my calculator forever to figure. You don't have to split it up unless the only time you want to do that is if you're given something like it's a non-calculator problem and you've got some kind of graph or something that you're, or maybe it's even something, you know what I'm saying, where you're using shapes to find area. you'll want to split it up like that. But if you've got your calculator on there, just do that absolute value and let it do it for you. Yeah, I think you probably did. No, not for that one, not for the total distance traveled there. Because that's only when you're talking about position. That doesn't have if you think about how far it actually went, that's not really impacting how far it went. Doesn't matter where it started or how far it goes, if that makes sense. All right, let's look at the doozy. The whole thing. Part A, find the area of the region in the first quadrant. So we know that area is the integral. I'm going from 0 to 2. I hope you could look at that equation and know that ended there at 2. And it told you to let C be 6. So 6x square root of 4 minus x squared dx. 3a. Again, this is not a calculator problem, which really stinks because I have to integrate this by hand. So I need an antiderivative, which means I need to use substitution. I let u be 4 minus x squared, which meant du was negative 2x dx, which meant I needed to divide this by 3, which means that I multiply by 3 here, and actually it needs to be negative and negative. So now I have negative 3. I am going to adjust these bounds so that I don't, yeah. Because that equation, cx times the square root of 4 minus x squared, where is that going to be 0? Well, that's definitely going to be 0 here when x is 2. And negative 2 really doesn't matter. Because this is that multiplied product rule here. So when x is 0 and when x is plus or minus 2, the negative 2 is not in my domain, so I go with the positive. I'm going to adjust these bounds quickly. Let's see. 4 minus 0 would give me 4, and 4 minus 2 squared gives me 0. And now I have u to the 1/2 du. Flip them around since the smallest is on the top. 3 times the integral from 0 to 4 of u to the 1/2 du. And now I'm ready to do the antiderivative. I've got 3 times, this will be 3 over 2, so 2 over 3 u to the 3 over 2 from 0 to 4. 0 is just going to give me 0. I'm going to plug in the 4 here. The square root of 4 is 2, and 2 to the third is 8. Oops, minus, of course, the 0, which would give me 6. Don't need any units here. Units weren't defined. Oh, units were defined. It says both measured in inches. I didn't put units on mine. I did not either until just now. Four to the 3 over 2 would be the square. This is the sunshine. Square root of 4 to the third power, which is 2 to the third. B stumped me. B stumped me because I was steady trying to use a cross section to estimate area, and that's not what they wanted. The part that I missed in part B was that word largest. Largest means maximum. Maximum is where a derivative equals 0. They gave you the derivative, so all you had to do was set that derivative equal to 0. Where does it equal 0? Well, really, what was it? C times 4 minus 2x squared over square root of 4 minus x squared. Where's that equal 0? So where's the top going to equal 0? So you just set that top there equal to 0. You find that x is the square root of 2. It's actually plus or minus square root of 2, but again, negative square root of 2 is not in my domain, so don't have to worry about it. My domain, of course, is from 0 to 2. Looking at the graph, I know the domain is restricted 0 to 2. I set this top equal to 0. If you divide by a constant, it's still going to be 0. So 4 minus 2x squared equals 0. Negative 2x squared equals negative 4. So x squared equals 2. And then take the square root. So I'm still not done because this said, what's the value of c, right? So I've got x. So then I have to go back to that equation. The y equals cx times the square root of 4 minus x squared. And I'm going to plug this value in for my x's. And I find that this actually equals 2c, which is still not what they want. That's telling me at the highest point on the graph, the y value is 2c. Well, they already told me what the highest point on the graph is. The highest point on the graph is the biggest radius, and the biggest radius is 1.2. So where is 1.2 equal to 2c? 0.6. That I thought was the hardest one on there. There were so many things you had to go back and plug in that you really had to understand what, and to use the terminology cross-section when you're so used to seeing cross-section to estimate volume and whatnot that it was really, really hard to, that one was tough to navigate through. Part C, another spinning toy, the volume. So here we go with the volume is 2 pi cubic inches. What's the value of C? This one I thought was a little bit easier. So, you know, volume is the integral of area. And this is how I work through things in my brain. I did this. I know that if I integrate area, I'll find volume. So what I need to know is an equation for the area. So I know that the area of a circular cross section here was pi r squared. Pi, it gave me the radius there, right? Cx times the square root of 4 minus x squared squared. This is what I'm integrating from 0 to 2. I distributed this squared through here, 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 and here. So I ended up with the integral of, from 0 to 2, of pi c squared x squared times 4 minus x squared. I'm sorry, I'm late. But I pulled these out since they're constants. Right? Any constant can just go right outside of that integral. I'm from 0 to 2, and I distributed this through 4x squared minus x to the 4th. Now it's something that you can do the antiderivative of and evaluate.